You know, there's a silent killer lurking in your software. It's not some bug that crashes the whole system. Nope. It's an invisible force that slowly, quietly cripples your application, frustrates your users, and absolutely tanks your business. We're talking about performance bottlenecks. So how do you fight an enemy you can't even see? Well, that's exactly what we're going to figure out. And Jorge Ribera just nails it with this quote. See, performance problems aren't always these loud, obvious errors. They're subtle, they're deceptive. They're like chameleons hiding in your codebase, just blending in. Finding them feels less like engineering and a whole lot more like detective work.
And why does all this detective work matter so much? Because a slow system isn't just a technical headache for you. It's a hugely expensive business problem that hits you right where it hurts, the bottom line. Let's really break down the real-world cost of being slow.
I want you to think of your application like a busy highway. A performance bottleneck? That's like a sudden, unannounced lane closure right in the middle of rush hour. What happens? Instantly, traffic backs up for miles, data gets congested, and your users, the drivers, get incredibly frustrated. It's the perfect way to picture how one tiny constraint can grind the entire system to a crawl.
And that frustration? It has a number: 3 seconds. All the research shows that if your site takes any longer than 3 seconds to load, a huge portion of your users are just gone. They've already clicked away. And that directly torpedoes your conversion rates, it damages your SEO, and it sends your customers running straight to your competitors. Every single millisecond really does count.
So when things start getting slow, engineering teams often jump to a few common conclusions. The usual suspects of performance tuning. But as we're about to see, these gut instincts can be super misleading, and sometimes they're just plain wrong.
Okay, the number one myth, the one we all hear: just throw more hardware at it, right? Things are slow, just spin up more servers. But the reality is, over-provisioning is often just a really expensive Band-Aid. It doesn't actually fix the underlying disease in your code or your architecture. It just hides the symptoms while your cloud bill goes through the roof. You're basically paying a fortune to ignore the real problem.
Another one of the usual suspects is the database connection pool. Now, this thing is critical, but it's also incredibly delicate and so easy to get wrong. For example, if you set the pool size way too high, thinking more is always better, you can actually overwhelm and crash the database itself. Set it too low, and your application is just sitting there, starved, waiting for a connection that's never free. And if you get the timeouts wrong, you can create these massive cascading failures across your entire system. Every single one of these settings is a hidden trap just waiting to spring.
So, if our usual fixes are often wrong, maybe the problem isn't the fix, maybe it's how we're identifying the problem in the first place. And this brings us to the central twist of our whole story. What if the very tools we use to measure performance are fundamentally lying to us?
Come on, we've all been here. You're staring at the dashboard. The average response time looks amazing. The 95th percentile is totally fine, well within your SLA, everything is green. But users are still complaining that things are slow. So what gives? What if the problem isn't your system, but the metrics themselves? What if your dashboard is lying to you?
We have this tendency to dismiss high percentile latencies, like the 99th percentile, as just rare edge cases. But they aren't rare at all. Just look at this. A single visit to CNN's homepage generates 127 separate requests. When you do the math on that, it means a user has a 72% chance of hitting one of those supposedly rare, slow requests on just one page load. It's not an edge case. For a huge number of your users, it's their entire experience.
And this brings us to the main culprit, a phenomenon called coordinated omission. It sounds super fancy, but it's actually deceptively simple. When your system stalls or hiccups, like say during a garbage collection pause, your measurement tool also pauses. It stops sending requests, which means it stops measuring response times at the exact moment they are at their absolute worst. It's like our tools are in on a conspiracy to selectively ignore all the bad news.
Okay, let's see this in action. Imagine your system completely freezes up for 100 seconds. A benchmark suffering from coordinated omission will show you this. Look, everything is perfect, 1 millisecond latency across the board. The 100-second stall is completely invisible. The data looks absolutely pristine.
But this is what your users actually felt. The 75th percentile latency wasn't 1 millisecond, it was 50 milliseconds. The max latency was 100 milliseconds. The tool reported a perfect, healthy system, but the reality for your users was a complete and total disaster. And this is so dangerous, because when you have bad data, better can actually look worse, and you can get tricked into making the exact wrong decision to fix it.
So here's the core of the whole deception. Flawed tools measure what's called service time. Think of it like this. That's the time it takes a cashier to scan your items once you finally get to the front of the line. But what your users experience is response time, which is the time they spent waiting in that massive line plus the service time. Coordinated omission completely, totally hides the time spent waiting in line.
Okay, so if we can't blindly trust our dashboards, we need a whole new approach. We have to stop being passive observers of our data and start thinking like detectives, systematically hunting for the truth and challenging every single assumption we have.
And this detective work follows a few key rules. Rule number 1, make it fail. You absolutely cannot fix what you can't reliably reproduce. 2, quit thinking and start looking. This is huge. It means you stop assuming you know what's happening and you start actually verifying every single step. 3, divide and conquer. Methodically shrink the problem space. Comment stuff out. Turn things off. Do whatever it takes until the bug has nowhere left to hide. And finally, work backwards. Start from the error and trace your way back to find its true origin.
Now, fixing bugs is one thing, but really, the best strategy is to prevent them from ever happening in the first place. This means we have to build performance into our development culture from day one, not treat it like some afterthought we'll get to later.
Building a real culture of performance means adopting proactive habits. You have to integrate load testing right into your development cycle, because believe me, it is so much cheaper to fix things early. Automate your monitoring so you catch issues before your users do, and standardize your practices to avoid common traps. For instance, the inter-platform effect. That's where a team accidentally rebuilds a slow, clumsy version of a tool that already exists. It's a huge waste of time and a total performance nightmare.
If you only take one thing away from all of this about performance tuning, let it be this. At the end of the day, it all boils down to two simple laws of physics. 1, do less work. And 2, do the work you have to do, but do it faster. Every single optimization, every architectural choice, every line of code you refactor is ultimately serving one of these two fundamental rules.
So I'll leave you with this question. The next time you look at your dashboards and you see that beautiful sea of green, I want you to stop and ask yourself, are you measuring the service time that makes your system look good, or are you measuring the response time that reflects what your users actually feel? Are you measuring what's easy or what truly matters?